Live doing some chemistry experiments today. Yes, indeed. Let's turn this one off. I'll keep this one spinning. I'm gonna add a little bit of let's add a little bit of sodium hydroxide over here on the right. Uh-oh. Looks like my bottle's curses. Of course I would have to. Oh, nuts. I'm gonna have to. Maybe this bottle will work over here. I hope so. Yep, good. This one will work. How you doing there, Rage? Welcome aboard. We're doing some simple chemistry experiments. A little bit of a universal indicator. I'm adding some sodium hydroxide over here on the right to a solution of universal indicator. Stirring on a stir plate. This one over here is stopped. I'm going to go ahead and add the sodium hydroxide over here. You can see the sodium hydroxide when I add it, it changes to a violet color. I'm going to add another drop here. We're going to see what happens over time in this flask over here on the left. The one on the right, I'm going to keep spinning. It's kind of fun what happens over here on the one on the right. Let's add some hydrochloric acid, same acids found in your stomach. You can see when I add the hydrochloric acid, everything shifts to a, oh man, like to a red color. We're also seeing parts of the rainbow, aren't we? It's beautiful. Make it purple. I did down here, Rage. Yeah, a little bit of violet color down there. What do you say? We'll definitely make it some purple. Yep, we'll be making some purple for sure. Yeah, a little bit of base over here. It's kind of fun to let it go static. Thank you there, Rage. I appreciate that. I definitely appreciate that. So the indicator you're looking at, it'll show these different colors at different pH values. You can see over here on the right, it's got like a violet color, and that indicates pH 10. Watch what happens. Let's watch what happens when I go ahead and add some acid to this flask over here on the right. There's one drop. Thank you there, Rage. I appreciate that. Here's 2 drops. Here's a 3rd drop. Actually, a 4th. Another one fell in. Got a little flash of the rainbow. Me too, Rage. How you doing there, Mew? Hey, we got a little flash of the rainbow over there. That was kind of nice. Look over here. You can see that the sodium hydroxide solution that I added, it sunk to the bottom. And that made the bottom kind of a violet color. Here in the middle, it's looking kind of yellow. That's because, you know, the acid and the base are neutralizing each other. So you're going to see more neutral pHs where the acid and base combine. Over here, we've got pH 6, it looks like. Let's add a little bit of base. Sodium hydroxide base. Yeah, and that shifts it really quickly to pH 10. This one's not working so well. I'm going to go ahead and just spin this one up. I wonder what color it's going to end up. If we have more acid, it'll be like a red, orange, or yellow color. More base, it'll be blue or violet. And if it's perfectly balanced, we'll get a green color. We got yellow. We're going to get yellow, maybe orange, yellow. So there's a little bit more acid over here than base. See, we got pH 6. Just add a drop of base here and see what happens if I do that. It'll probably make it go basic. Sure enough, a little bit too much base. I'm going to go ahead and turn this one off over here on the left. Over here on the right, I'm going to start adding hydrochloric acid to the dynamic system. I'm going to add a little bit of acid over here on the, like 4 drops over there on the left. It's beautiful, isn't it? See if we can catch the rainbow here. There we go. Another drop. Yeah, we got a dynamic rainbow, huh? It's kind of cool. I think this system might work better if I turn this one on. Well, let me get it red first. We'll get this one red. There we go. Turn that off. I'm going to mix this one up. If we have more acid, that's going to be red, orange, or yellow. More base, it'll be blue or violet. And if it's perfectly balanced, oh no, there's a lot more acid present in that one. Much more acid present. While that's spinning, let's add some sodium hydroxide base. See what happens. Couple drops. See if we get that rainbow action. No, I think that's just going to be red or purple. Let's see if we can get it going over here. Here we go. Let's go like 1, 2 drops in the static system. This one's being spinned over here. Hello there, Emma. Welcome aboard. Welcome aboard for some science experiments today. I'm dropping hydrochloric acid over here on the left. See what we get. Oh, that's kind of pretty. Kind of pretty. That's looking interesting, isn't it? All right, let's see here. We'll add a drop of sodium hydroxide. Boom, boom. See what happens? Got a little flash of rainbow action. This doesn't look like it's doing much. Interesting. All right, let's add some hydrochloric acid. You know what? I want to maybe try to set this up. Seems like we're having a little bit of trouble getting the colors. All the variety of colors today. I see a little bit of green and yellow in there. Just a bit. Just a bit. There we go. There we go. We're going to go ahead and acidify this. I'm going to continue to add hydrochloric acid, which is the same acid that's found in your stomach, except the stuff I add is a lot more concentrated. All right, I'm going to add 1 drop of base. Let's just see what happens. Come on, baby. Let's see. Look at those flecks of colors we're getting over here. It's kind of pretty. All right, let's try another drop of base. Just keep doing it 1 drop at a time. Thank you there, beloved. There we go. Get another drop of base there. See if we can get the whole spectrum of the rainbow. There you go, folks. We got a little rainbow action going on. Yes, indeed. It's the month of June. Happy Pride for those that celebrate. Every time we see that rainbow, I'm going to have to tell you that. Every time we see that rainbow. For those that celebrate, happy Pride. There we go. A couple drops of acid. You know, maybe we're going to get a static rainbow over here. Hello there, Cod. Oh, Co-Dragon Slayer. There we go. Let's add a drop of base. Try to increase that pH. So what we're doing here, I have universal indicator. Universal indicator displays the colors of the rainbow depending upon pH. So, you know, what I did in this flask over here, it was at first quite acidic, which is going to be like here. I'll add a bunch of acid over here on the left. So we're going to go ahead and make this acidic. At an acidic pH, thank you there, beloved. At an acidic pH, we're going to see a pH of 3, 4, 5, or 6. This is quite acidic because it's a pH of 3. The lower you go on the pH scale, the more acidic it is. Now what I'll do is I'll add some base, which should increase the pH. Here we go. There we go. Isn't that beautiful? Come on, give us a rainbow. Come on, baby. Yes. Yes, indeed. I think we got some rainbow color. That's Pride Month, so happy Pride to those of you who celebrate. And you can see we got kind of like an ethereal rainbow action going over here. Look at that. That's just beautiful. Beautiful pattern. Let's add another drop of base over here, see what happens. Here we go. We're going to add another drop of base to this static system. You can see the base is violet. It makes everything violet. And as it's more dense than the surrounding solution, so it sinks. Look at that gorgeous. Look at that pattern. That is just beautiful. Absolutely beautiful. I think we might develop a pretty interesting color over there. I am Co-Dragon Slayer. So what I'm doing is well, you know, the universal indicator is not that simple. It's a mixture of 4 different acid-base indicators, but you can buy it. You know, you can buy this pre-made. And the universal indicator displays different color. How you doing there, Clip? Clip by Gold. There we go. So here we go, right here. Hey, Lucky Lace, we're absolutely. I know that the rainbow is represented in the Bible, and I'm certainly happy to shout that out. And it's also used by folks to represent Pride Month, and we're going to celebrate that as well. So right here, we've got the universal indicator and how it displays various colors depending upon pH. At low pH, it'll be a pH of 3, and it'll look red, like we see over here. Yeah. Xtina, please don't be spamming the comments or I'm going to block you, all right? Fair warning. Let's go ahead and start adding. So this is violet. This is violet over here, which is a pH of 10. Last chance, Xtina. And I'm going to start adding some hydrochloric acid. Hello there, Benjamin. We're adding some hydrochloric acid. Thank you there, Clayton. I appreciate it. I appreciate you being in the stream. And you can see as I add, depends on what the word is, le poisson. It depends. Yep, CX Tina. Put user in timeout, 24 hours. All right, man, I hated people do that kind of stuff. Okay, here we go. Hey, look at this. We got like an aqua color. I don't usually get that. That's going to be a pH of 8. Now, if I start adding hydrochloric acid to the system, a couple drops of hydrochloric acid, the pH is going to drop. Thank you there, Richard. So now the color is shifting away from blue to more orange, yellow, and red. So there we go. And you can see here, you know, the pH is dropping. We're becoming more acidic. pH of 3. Let's add some sodium hydroxide to neutralize the acid now. And there we go. We got a little flash of the rainbow. Thank you there, Void. So happy Pride to those that celebrate. It's Pride Month. And look, it's green. It is green. That's a pH neutral. So I neutralized the solution, which is kind of cool. The pH is balanced. Let's go ahead and add some acid, make it acidic here. I'm going to add hydrochloric acid. That's the same acid that's found in your stomach. Thank you there, Dylan. So as I add the acid, you can see, snag it. There's really no end goal here. You know, this is a little bit of art mixed with science, okay? So you can see right here, we got like a pH of 3. That's going to be quite acidic. All right, and now I'm going to go ahead and add some base. I mean, I have other experiments if y'all want to do them. I've got some other ones planned. I can show you what happens as carbon dioxide dissolves into solution. I can show you that that's acidic. We can also do a Coke and Mentos experiment if folks want to do that. I got stuff ready for that. I can actually do that indoors. I've got a little way that happens, that I've got that to where I can do that particular experiment. Right now I'm adding hydrochloric acid to the system over here on the left. Hey, thank you there, Snaggin, Texas. Appreciate that. Hey, look at this over here on the right. We got an interesting thing going on here. Can chemistry be applicable in everyday life? So, Lupin, your teeth are made of chemicals. So, I think so. I think it actually is. Thank you there, Loki. Appreciate that. All right. What happens if you throw a lemon in there? Izzy, I wish I had one. I don't have a lemon down here in my basement. I apologize. But let's see what's going to happen in this case. In this case, notice. It's kind of fun. Yeah, so Yuna wants me to explain it. So let's explain what's happening here, Yuna. Thank you for that call out, and we're going to go ahead and do that. So in both of these flasks, I have water, and I also have some universal indicator added. Universal indicator is pH indicator, okay? And that just means it displays different colors at different pH values. So if you see red, like we do in this flask, we know the pH is 3, which is quite acidic. If I start to add base to the system, it's going to neutralize the acid. Here, let's add a drop of base. So in it goes. And you see some color changes because the acid is being neutralized. And that's going to change the pH. And sometimes you see like a whole rainbow of colors because the system is trying to equilibrate. Izzy, it is not drinkable. I mean, it is drinkable, but it would end alive because one of the ingredients is a laxative. So it would probably end alive in like 15 minutes or something like that. Anyway, we were at like pH 3, and I added some base, and notice the pH went up to 6, which is still acidic, but not as acidic as it was before. Now I'm going to add some more base. Here we go. So I'm adding base to a system that's at pH 6. Tell me about it. Okay, if this is actually live, so you can pull off a deep green. I'll try it, but that's tough to get. But I will try it. So anyway, notice I added another drop of base, and we went straight to violet. So we jumped from a pH of 6 to a pH of 10. So we went from acidic, past neutral, to, to purple grimace, says Artie. Hey, thank you there, Yuna. And that's a pH of 10, very basic. So over here, what's kind of interesting is we have a mix We have a, that's right, Artie. We have a mix of pH 3 and pH 10. And notice where the interface is, there's kind of a yellow-green color. And that makes sense because the acid and base are going to neutralize each other. Hello there, Artie. Okay, so what I'm going to do is I'm going to mix this up. Let's see where we land. So we're going to see if there's more acid or base present. Hey, thank you there, Antoshka. And it looks like there was quite a bit more base present over here. Thank you there, Charlie. What if I drop some oil in it? I wish I had some down here in my basement, but I don't. Let's start adding acid over here on the right. And look at that, we got the rainbow. We got a flash of the rainbow. So happy Pride to those who celebrate. It is Pride Month, so I want to say hello to any folks that are celebrating Pride. pH above 7, DHD 9, D7 is indeed alkaline. Thank you there, Artie. I remember back in school with titration, it was known to be very easy to go from acid to base as pH changes very quickly. It can. So Snaggin will be tuning in later. Thank you there, Snaggin. Thank you there, Machete. Hello, Jameson. All right, we're going to add some base now to something that's at pH 3, and that's going to make... Yuna, I usually do the lives on Sunday. Grab some stuff to stick in there. Thank you there, Charlie. Thank you there, DH. Here we go. We're going to go ahead and add some acid to this flask, and we're going to add some acid to this flask. You're welcome there, Yuna. Hey, let's do the Diet Coke and Mentos experiment. What do y'all say, huh? You guys want to look at that beautiful color, though. I'm getting a little mesmerized here. I don't know. I did, Antoshka. I did make piranha solution. If you want to see the piranha solution, you might want to check out my channel, Tommy Technetium. You can head on over to some of my shorts. In a YouTube short, I make piranha solution, and I put a scrub daddy in it. It does look a little bit like Graham staining. So, what other experiment do you do? Well, let's do the Diet Coke and Mentos experiment. What do you say, huh? You want to try that? I'm going to show you how we can do that. We can even measure how many bubbles are produced by a half-liter bottle. All right, we'll do it. Here we go. Let me set it up over here. Get a check out of the lab and all the gunk I got in it. Here we go. Look at this over here. What the heck is this? What is this guy doing? Well, I've got... Hey, you know what? You all are my homies. So I'm going to, and you got to forgive me sometimes when I'm setting up experiments, I can't read the comments quite as well. But you all are my homies, so we're going to share a Diet Coke with some homies. I'm going to place that right down there. Yeah, can you see it? Can we see the Coke down there? Yeah, we can. All right, great. So I can see it down there. And then I got this special tube that I'm going to put on top, okay? This special tube here, which we're just going to connect on the top. And then I can drop the Mentos down the tube into the Coke. Now check this out, though. This thing's a cylinder, right? I mean, it's a big cylinder, but it's a cylinder nevertheless. Yeah? And we know how to calculate the volume of a cylinder, right? Pi r squared times the height. So the radius of this cylinder is going to be the distance across here, right? Well, half the distance. And if we measure that in centimeters, you might see, and I'm starting at 1 over here, and it's going to 4. So that's 1.5 centimeters, right? Is the radius. Here, I'll do it this way. Yeah, it's 3 is the diameter, so the radius of this cylinder is going to be 1.5 centimeters, okay? And then what I have here marked on our cylinder, I have the height of the cylinder marked in centimeters. So here's 10 centimeters, 20 centimeters, 30 centimeters. So we're going to be able to figure out the volume of foam produced, okay? We're going to find the volume of foam produced. Okay, here we go. We're going to go ahead, and I'm going to attach this to the top of this bottle, and then we're going to see how much Diet Coke foam we're going to produce. I got my Mentos down here. I'm going to open this baby up. Try not to get rid of too much CO2. All right. And then I'm going to attach this to the top. I'm going to attach this to the top here. Forgive me, I can't read the comments right now as I'm setting this up. But I got to really try to cramp this down. It's hard with these new bottles they have. I think I got a good seal. I think I got a pretty good seal. All right. And then that's all set up. How high do you think it's going to go? So there's what? 10, 20, 30, 40, 50, 60. That's like a meter high right there. And that's 1.2 meters high. So just the Dino Nerd says 40. Moy says a billion miles. Tio says 50. Una says all the way. We got a bunch of 40s and 50s. Artie says 60. Someone, I apologize, I can't read that language, says 95. Yes, it is DD97. Johandri says 120. Here we go. Get your bets in, folks. Let's do the Coke and Mentos, and we're going to measure the volume produced. All right, here we go. Look at all those bets. All right, folks, let's see. Here we go. The length of the universe. I see ya. All right, I'm not reading comments. Here we go. I got to hold it, though. And I'll bring it in so you get a close-up. 1, 2, 3, and it goes. Oh, baby. Come on. It's going to go at the top. It's going to. No, it isn't. 90. Y'all see it went to 90? Maybe 89. And what's cool, look in there. You can see the bubbles. Those bubbles look beautiful, don't they? Absolutely gorgeous. So down it goes. And now you can do a calculation, right? We can do a calculation to see. Look at those bubbles, though. I want to just look at those bubbles just for a bit. They really are pretty. So would it have made more bubbles if you put in more Mentos? You want to find out, Lord? Let's find out, huh? We can do another experiment. Let's do more, okay? But first, let's calculate. Let's just calculate how, the volume of foam produced. So what was it? Here we go. Let's see here. We got to do pi times the radius squared times the height. So let's see. 3.14, that's pi, to 3 digits. That's going to be fine. All right. Times the radius squared, that was 1.5 centimeters, times 1.5 centimeters, that's the radius squared, times the height, which was 90 centimeters. So that's 635 cubic centimeters, 636 cubic centimeters, and that's a cubic centimeter is a milliliter. So long there, Una. So this went 636 milliliters high. 636 milliliters high. And, I have done measurements on the radius of the bubbles that are produced. And the radius of the bubbles are usually about 3 millimeters, which is 0.3 centimeters. Well, you can calculate the volume of each bubble. So if you want to go ahead and do that, you can calculate the volume of the bubble, and you just take that 636, you divide it by the volume of the bubble in centimeters cubed, right? Volume is 4/3 pi r cubed. And you can find out how many bubbles we produced. Here, let's do it. Here we go. So it's going to be 4/3, 4 divided by 3, times pi, times the radius cubed, which would be 0.3, times 0.3, times 0.3. So it's 0.027. Did I do that right? 0.3 would be the radius, is that right? Let me just do that one more time. 0.3 times 0.3 times 0.3. Yeah, that's 3 millimeters cubed, yeah. No, that's 3, yeah, that's right. That's 0.3 centimeters. Yep, times 3.14 times 4 divided by 3. I'm messing up here. I'm having a hard time. This is hard to do live. 4 divided by 3 times pi times, that looks right, yep, times 0.3, yep, times 0.3 times 0.3. There we go. There we go. So it is 0.11. That's per bubble. Yeah? 1 over, that can't be right. Something ain't right with my math here. Anyway, we got 636 divided by 0.1. About 6,000. I don't believe that. It's got to be more bubbles than that. Anyway, all right, Artie, let's do it again. Somebody made the suggestion, let's do this again, but let's do it this time with more Mentos. All right? So this time we're going to do it with a goat. This time we'll do it with a goat. Let me move this one out of the way. It's going to take me a little bit to get this off, so I have a fresh one that I'm going to use. I do have another one. It's the same size, folks. It's the same size tube. Same setup, all right? Same setup. We're going to attach it down here and drop in the chat how many Mentos I need to drop in. Last time I did 1. So long there, Artie. How many are we dropping in this time? Go with a 2-liter and lots of Mentos. I don't know. I think a 2-liter would hit my ceiling. So Mr. M says 3. 3 to 5 says Lord. Velazar says 5. Alex says 3. Yohandri says 4. Big Ben says 8. I don't know if I can get 8 down the tube that quickly. It looks like, roughly speaking on average, I think it's going to be about 4. So here we go. We're going to go get 4 Mentos. Well, you could do the 2-liter. Yeah, that's true. I could do the 2-liter outside. So there's 1. There's 2 over there. So there's 1, 2. Engineer says solid. Once 25. Mako says 5. Status says 3. So I think on average, folks are saying about, it's hard to video and get the Mentos out at the same time. Definitely Fruit Mentos, baldest. You got it. That one is going in the mouth. Tasty. Okay. Let's get it set up here. Sorry to hear me eat the Mentos as we're doing the live here, but that is good tasting stuff. All right, we're doing 4. Drop it in the chat if you remember how many we got last time. How high up did we go? 90 centimeters, right? Yep, 90 centimeters. Okay. Yep, Lord got it right. So I got these 4 ready to roll down here. We're going to watch me attach it. If this shoots out the top and I got to clean out a mess, my wife's not going to be happy with me. All right, here we go. Let's get it attached here. I don't know why I'm worried quite so much about. There we go. That's a good seal. That's a decent seal. This baby's ready to roll. Let's do it. Nice and balanced. I got my Mentos ready. And I'm going to stick them in. I want to just make sure we got a good view here. I'm going to keep it balanced this way so you can see the top. Yeah, the top is like right here. All right? And 90 is right, 90 is right here. All right? So 90 is right here. I'm going to try to keep my finger on the 90 after I drop these down. Everybody ready to roll? Here we go. All 4 in. 1, 2, 3, 4. Ah! I got a mess. It went a little higher. Oh, beautiful. Let's see if we can see those bubbles. You see it foaming out the top there. Look at those gorgeous bubbles, huh? Aren't they just beautiful? Really pretty. Yeah, we went out the top. Oh, man. Yeah, we went higher than 100. We went like, I don't know, 123 plus. I'm going to need a bigger tube. Engineer John, I need you to design a bigger tube for me. Look at those gorgeous bubbles. Well, what I like about this is it lasts, it lasts a little longer. I need better lighting so we can really see the glistening of those gorgeous bubbles. I'll try to see them down here. Really pretty. Yep. There's still some bubbles moving up, but the foam is collapsing, and so it's definitely moving down. We're down to 60, 50. Yeah, the foam is collapsing. Yeah, I should probably do this outside. Alex is saying we want 140. Yes, it is centimeter, Velazar. Because I am a true American patriot. True American patriots use the metric system, baby. Regardless of what those knuckleheads will tell you. Okay, here we go. Back over here. Oh, yeah, honeycomb structure indeed, Baldy. Baldus, excuse me. I didn't mean to call you Baldy. Velazar, thanks for the note there. One is purple, one is blue. Can you see the difference? I see it. I definitely see it. So this one's going to be a pH of 10. This one's going to be a pH of 9. Yeah? Just barely difference. I'll add 1 drop of hydrochloric acid to each. So I'll add 1 drop over there. Actually, 2 went in. And we added 1 drop over here on the right. Oh, we got a flash of the rainbow over there. Happy Pride to those that celebrate this month. It's Pride Month. Happy Pride to anyone who's celebrating. Over here, we're going to add a little bit of hydrochloric acid. Hello there, Case. Another drop of blue. I got one more experiment for you here. What's up there, Bat? We're going to call you Bat. I hope you're okay with that. That was fun doing some Coke and Mentos. I got one more if you want to do it. I don't know if the other one, though. I don't know if the other Coke and Mentos tube that I have has markings on it. Anthony, what I am doing is in each of these flasks, I have some universal indicator, which displays these colors depending upon pH. So in the flask right now, this is a pH of 10. It's violet. This one over here is a pH of 9. It's blue. Those are both very basic. If I start adding some hydrochloric acid, which I'm going to do over here on the left, there's 1 drop. Hydrochloric acid is the same acid that's found in your stomach. This is just a lot more concentrated, like 1,000 times more concentrated. Well, I better add another drop over here. There we go. I see a flash of red because the hydrochloric acid is very acidic. And it's going to neutralize. You might see some flashes of color that are changing in here because the hydrochloric acid, it neutralizes the base. Let's add another drop. And as it neutralizes the base, it's going to bring the pH down. Thank you there, 0x. Thank you there, Kay. I appreciate that. Tennessee, hello. I got a sister that lives in Tennessee. Hello there, UBI. So you notice we started at violet, and now we moved down to maybe pH 8 or 9. It's kind of like a bluish color. I'm going to continue to add acid. There's another 2 drops. It probably was, Lord. You're probably right. And it looks like hey, there you go, SI. we are down to like a pH of 6. It's like yellow in color. So we've now acidified the solution, but just slightly. So I'm going to continue to add acid. We'll add another drop or 2 of acid over here. And now, of course, it's definitely acidic, Velazar. So we are like pH 3. We'll do the same thing over here on the right. I'm going to start adding acid. There's a drop of hydrochloric acid. Oh, that one went quickly, didn't it? We got a flash of the rainbow. A beautiful rainbow. It's Pride Month over here in the United States, so happy Pride to all those who celebrate it. I guess it's a worldwide thing. Why is one spinning faster? Here, I'll just make them both go the same speed. There we go. Thank you there, Tiramisu. Hello there, SI. Let's add another drop of acid over here on the right. All right, let's start adding drops of base. So I'm going to add a drop of base to each side, and as we add base, the pH should go up. So we're going to see a shift to different colors. Can I try it with citric acid? Aeon, I am using hydrochloric acid. 0. I could drink it, but it would probably end the live in about 15 minutes because the universal indicator is made of a mixture of chemicals, and one of them happens to be a laxative. Yeah, Lord, one of them is buffered. I think it's this one. One side is buffered a little bit more. That's correct there, Garouge. The base is sodium hydroxide. Hello, welcome back, Una. If you get it in neutral, yeah, I mean, Baldus, I could put my finger in it. I mean, the concentration of chemicals is low enough that it's not gonna mess with me too much. Hello, administrator, what's going on? Getting our flash of the rainbow. Nope, it's not there. Good to have you on board, administrator. Here we go. We're going to put a few drops of acid over here on the right. H, I'll try to make one pH of 7. I'm doing okay, administrator. Here we go. It's a little tough to do. Yeah, it is a challenge. We're going to try it, though, okay? So notice we're at pH 6. We're going to try to get it to neutral, which is pH 7. The base is really concentrated. All right? It's really concentrated. So what I'm going to do here, I'll zero in so you can watch what we do. So up here at the top, right here, I'm going to try to add a fraction of a drop. And I do that by putting my dropper bottle the tip of it right on the side of the glass. And I'm just going to squeeze until it gets just a little, you see that? It just got a tiny drop that's adhered. I don't know if you can see it. Yep, there it is. You can see that tiny drop that's adhered. So it's not a full drop. And I'm going to tilt the flask so that tiny drop goes into solution. So here we go. Let's tilt it in. Let's see what happens. Let's see if I can get to the green. Well, it looks like I got green up top, but let's see what happens when it goes in the whole solution, okay? Let's see what happens when it homogenizes. Oh, nope, there's still too much acid present. I'm going to have to try again. So we're going to try this trick again. I'm going to just put a little... Oh, the drop went in. Oh, that was acid. I'm in good shape here. Here we go. We're going to go... There, we got to go a little bigger drop this time because I accidentally put some acid in there. So let's go ahead and tilt that baby in. And let's see where we go. The acid I'm using is 20% by weight hydrochloric acid. It was a peach color for a bit. Let's try it again. I'm just going to really slowly do this. Continue to add fractional drops of base to try to get this to the green color. I think we might do it this time, folks. Come on, baby. I think I got to yellow-green, but not quite green. We're going to try it again. Here we go. We're going to try to add a fraction of a drop. This one I got to go. This is so close. So I'm just going to just barely touch this. I think this might do it. And it goes. Let's see what happens. Yeah, we can do that 0. I still didn't have enough. The main purpose of this experiment is for people to enjoy science in an artsy way. But I can tell you kind of the science behind what's going on. So in each flask, I think I may have overshot. No, there it is. We got the green. Maybe it's a bit aqua, huh? Purple's easy. Here, we'll do purple real quick. We'll just do a big old squirt of base in there. And there's your purple. Purple's really easy to get. Coffee says it's boring. It is kind of blue, Una. I agree. It is. It is definitely kind of... So, hey, you know what? I know what to do. I know how to acidify this. Let me show you how this is done. We'll go over here. I can fine-tune this over here in this system. Here, we're going to fine-tune this, all right? Let's get this light going and make it look a little prettier, okay? And now what I'm going to do is I'm going to add some of this slightly blue-green solution. Although in this view, it might look, well, who knows? We'll just try it here. Pour some in. There we go. Okay. Now what I'm going to do is I'm going to exhale. Yeah, that does look, that looks kind of green-blue, doesn't it? Yeah? I don't really know. Well, I can add acid directly, Coco, but the issue with adding acid directly is it's really tough to get it balanced perfectly. So, that is a little bit blue. So what I'm going to do is I'm going to exhale into this solution through this straw. All right, Vay, so long. And the reason why I'm going to do that is because, we all know that we exhale carbon dioxide. But the thing is carbon dioxide is an acid. So I'm just going to exhale just a little bit here. Here we go. Let's give it a swirl. Did that do the trick? Is that green enough for you? Let's go a little more. It is a bit. Here, let's do the control on the other side. I should have done that. This is the one I have not. So I have not breathed into this one. All right, add a little more here. There we go. So the control is over here on this side. And you can see it's got a little more cyan color to it, can't you? How can one calculate the pH of a solution without using an indicator? Oh boy, you can use a pH meter. I'm going to just give it a little more blow here so that this should lower the pH a little bit more. I hope I don't go too far. Yeah, sure enough. You can definitely see a color difference between the two now. And that should make sense because, carbon dioxide's an acid. So, of course, when it dissolves into water, it's going to lower the pH. Red cabbage. It looks like red cabbage. Here, I'll show you this too. This is kind of fun to do. This is a little bit crazy. I'm going to add a drop of base now. There we go. Big old drop of base. Swirl that around. Holy mackerel. Look at all that violet color. Yeah? So now what I'm going to do is I'm going to exhale into this through the straw. And we're going to watch what happens to the color. There's a lot of base in there. This might take a while. Let's see. Woo, it's not changing color, but my face is. My face is red. Here we go. Man, that's taking a while. I'm starting to see a color change. How about y'all? That's looking blue. Let's go a little bit more. Now it's a little more cyan. Now that's about a pH of 8. I think that's pretty close to neutral. What do y'all think, huh? What do y'all think? No, I'm not drinking it by accident. Yeah, look at that. And you know what's kind of neat is you can see, did you notice when I first started, this looked a little more blue than this, and now it has faded to more greenish yellow? That's because the reaction between carbon dioxide and water is quite slow. And you'll notice this will continue to fade over time because it's just a slow reaction. It takes some time. Can I give you the definition of pH? I can. It is the negative logarithm base 10 of the H plus ion concentration. I know that's a really technical sounding thing. It is. What acids do when they're in solution is they donate ions called H plus ions. And so, the pH is mathematically defined as a negative log base 10 of the proton concentration. It's really, if there are any chemists in here, it's not really the concentration, it's the activity of the protons, but nevertheless. Hey, let's see if I can get this to go yellow, all right? Here we go. I'm going to see if I can get this to go a little more acidic. So we're going to try to, it's somewhere in this region. I'm going to try to get it down to pH 6. Here we go. All right, baby, come on now. Remember, the reaction's slow, so this might fade to yellow over time. It's still got a tinge of green in there, but I think that's close to yellow. Yeah, it's looking kind of yellow. Sorry, I got to turn the light off so I can read the comments here. Give me a second. I'm going to turn the light up so I can see a little better. Hey, thanks, Kyle. Thanks there, Kyle. I don't have any dry ice, administrator. Sorry. And that's how you make Mountain Dew at home, huh? Oh, that's funny. Highlighter yellow. Yes, indeed. You know what? This light box looks kind of cool. I'm going to go ahead and I'm going to add a drop of base over here. Let's just see what these color changes look like over here on the light box, just for fun. Oh, that's a gorgeous violet. Man, that's a pretty violet color. Let's get the acids going so we can see the color changes that happen with the acids. Just put, let's see, we're going to do like 3 drops of acid. 1, 2, 3. This is kind of fun. You just kind of wait and you say, abracadabra, you give it a swirl. Isn't that fun? Oh, man. Yeah, absolutely, Una. You know, like citric acid. That's in your body. You know, you need citric acid to survive. So, yeah, and citric acid's found in, you know, in citrus fruits. So let's put a few drops in here. We'll do the same thing. Abracadabra. And there's your color change on the swirl. Yep, they do put acids like the Sour Patch Kids. They'll put stuff called malic acid in there. Very sour stuff. Oh, that'd be an administrator. I have done the iodine clock reaction in a video. I know how to do it with household chemicals, but you're going to have to go back and look through my old stuff, my old long-form videos to find that. We did get an orange. Here, let's do a little drop of violet over here. Excuse me, a drop of base. Another drop of base. See where we end up on both sides. This one's buffered a little bit. And what a buffer is, well, that went to orange. Let's see what this one, a buffer is something that resists changes in pH. Look at that, it's like a nice green. We'll do another drop over here. That's a gorgeous green. So yeah, this system is going to be buffered because I blew some carbon dioxide in there. I'll put another drop in here. I'll show you what I mean by buffered here again. So hold on, I got some comments coming through. So what is making it change color exactly? I get the reaction, but is it a change in molecules or something completely different? In your opinion, what's the most complicated yet worth it to do experiment? Oscillating chemical reactions, administrator, are really cool to do. Thank you there, Tiramisu. Hello there, Apostolo. Can I melt some beef? I don't even know what that means. What pH is base? Linda, a base is anything with a pH greater than 7. Jesse. I fired Jesse. Yes, I have, Lord Stormia. I just, I don't mess with that anymore. I've learned that it's not very safe. No, it ain't that, Lim. Yeah, it's a beautiful green. Now, there was a question back there. Somebody asked, sorry. I'm going to get into this. It takes a little bit to describe. So Kyle wants to know what makes it change color. So I'm going to give you like a general idea of how this happens, Kyle. But I'm not, and while I do this, I'll just keep dropping stuff in here so, we get to see some color changes. Remember, this system's got some carbon dioxide in it, and that's going to maybe react with the base that I add, and there may be a slow reaction. Anyway, the way this works is there's 4 different dyes in here, and it's the combination of those 4 dyes that give you the color. Well, one of the dyes is what we're going to talk about. It's called phenolphthalein. So let me show you the pH scale for phenolphthalein. It looks like this. I'm just going to talk about this one because it's the simplest. It's the simplest. So phenolphthalein is going to be colorless at like pH 3, 4, 5, 6, 7, and 8. And then if you get it to a pH 9 or 10, it turns into a pink color. All right? Administrator, you don't want to drink this. This phenolphthalein is a laxative, and it's in there. So you don't want to be messing with this. Anyway, so here's what goes on with phenolphthalein. See, phenolphthalein happens to be a ring-shaped molecule. It's got a lot of carbons in it, and carbons can make rings. And we're gonna say it's like this, okay? So it's got a ring-shaped structure. Now, it only takes on a ring-shaped structure in the presence of acid. And what acids do chemically is they donate protons. And we're gonna say protons are these little H plus symbols here. You can think of the H plus ions as floating around in the water when there's a lot of acid present. And what the phenolphthalein molecule does when it sees H plus ions is it grabs onto it like this, cronk, and it makes the ring shape. And when the phenolphthalein has a ring-shaped structure, it's colorless. Now, when there's a lot of base around, the base will steal these protons. Bases are good at stealing protons. Now, there's plenty of base around. These protons get stolen from the phenolphthalein, and that's going to happen at high pH. What happens, however, when the proton gets removed from the phenolphthalein is it goes like this, doink. So it's ring-shaped, but if that proton's lost at high pH, it goes boop, it pops open like that. And with that change in structure comes a change in color. Colorless in an acid, boop, pink in a base. So it's all about chemical structure and changes in those chemical structures that cause changes in colors. Hello there, Aunt Keat. Don't get stuck in a loop, steal some stuff. Iron, solid iron plus copper to make. Oh, that's an interesting. What's the difference between acid and base? So, Una, an acid is a substance that donates these things. So it gives them to the solution. And then a base is going to be a substance that steals these things, grabs onto them. That's the difference between an acid and a base. And there's multiple ways to define acid and base, but that's a very common way to define them. That's correct, administrator. Ring-shaped as in well, you can't have cyclomethane. You almost got me on that. Cyclomethane, that's just one carbon. So you can't have, cyclomethane. The smallest ring structure that you can have in an organic molecule is 3 carbons. So that'd be cyclopropane, but that's a pretty unstable molecule. Is there a correlation between charge density, energy density, and pH? So yes, James, we can talk about charge density. So if you are at low pH, there's a lot of protons around. The molecules that grab onto those protons are going to be more positive. So molecules that can accept and donate protons like phenolphthalein, they'll be more positive in acid, but less positive in base. It sure does, Roatan. If you want to see it, you can check out some of my videos on my channel. I have some videos where I definitely put some sodium in water, and we enjoy that. You're going to check out my my YouTube shorts to see those. Give me a second here. I got to scroll through the comments here. Do a little swirl on both of these. We can see kind of some action going. Hello there, wrestling. We got the wrestlers entered the chat. I was a wrestler there, Wrestling Proud 87. I graduated in 86. Looks like you might be an 87 grad. Notice how a single drop can cause such a giant change in pH. It does, Lord. Isn't that funny? Vivianite crystals. I've never heard about that watch, but I'm going to have to check it out. Vivianite crystals. Thanks for the tip. Unit. I have done a video with potassium permanganate. You'll have to look into my old stuff. I use it to measure, I think it's the amount of oxalic acid in rhubarb. The Grinch has been melted and has turned into Grimace. I'm not that kind of chemist there, Velazar. Got you there, Roatan. You got it, Administrator. Happy Pride. This is a similar reaction to when I don't know the experiment in our solution. Sorry, when the liquid... Yes, it does look like that. It's a reunion. I've not done a video on ruthenium proper, but I have done a video on the ruthenium complex that luminesces. No, I've never done a video on the ammonium dichromate, and I probably won't, Administrator. the reaction that produces that ammonium dichromate volcano, it produces some chromium compounds that are carcinogenic. And I'm not going to mess with that. Alvin, if I drink it, it's going to end the live in about 10 minutes because one of the dyes that's in here is a laxative. So I'm going to make sure I'll be washing my hands. Yeah, Baldus, we did some other experiments we did today. We did the Coke and Mentos experiment. I got one more that we can do. If you want, I do that indoors. Alvin. Yes, Lord, the Pharaoh serpent is deadly toxic, but however, I figured out a way to do it where it's, it doesn't use the mercury compound. Do I have any good tips for studying chemistry in a university? Learn how to love it. You know, hopefully you love it. Sorry I'm leaving these colors here, but I graduated from the University of Michigan, and that's just kind of looking pretty to me. So I'm just going to leave that there for now. Hail to the victors. It looks kind of nice. I don't know what TCCA is there. Chemicals taste good. You might have to give me a little information. Minion creation process. Hello there, Grayson. I'm not going to die from a laxative, but I don't want to. These solutions are schizophrenic. That's funny. Sand with lighter fluid. Interesting. Black cart. Yeah. All right, here we go. Let's add a drop of base over here on the right. And we're going to drop a drop of acid over here on the left. We're giving both a swirl. Let's see where they end up. Well, the blue is fading to green. The blue is fading to green. There we go. We got Christmas colors. We're not going to have Christmas in June, though, but we definitely got some Christmas colors. The chemicals used in the elephant toothpaste experiment, that's going to be hydrogen peroxide with a little bit. I'm adding base over here on the left. Hydrogen peroxide with a little bit of potassium iodide solution. You add some detergent to catch it in the, to catch the oxygen gas produced in a foam. I agree, Kyle. It's very pretty. Thank you there, PA. I hope you understand why I'm abbreviating your name. Yeah, the hardest to make is definitely green. We can try it again. Remember how I did this? We'll try to make green. Here we go. I'm going to use this solution here. That'd be fun, administrator. Favorite part of the job is to get the prettiest colors. All right, here we go. Green's not that tough. Green, what I'm going to do over here is I'm going to exhale into this solution with the straw. The reason why I'm going to do this is because the solution is currently at like pH 8, which is basic. Carbon dioxide's an acid, and so this requires some fine tuning. I'm not real good at doing it this easily, but if I exhale some carbon dioxide into the solution, that should be just enough acid to acidify the base and make everything neutral. So let's see. Forgive me for a second. I'm gonna stop reading the comments hey, thank you there for the sub there, PA. I'm gonna go ahead and breathe into here, and we're gonna see if we can get this to go green. Here we go. Now, the reaction between carbon dioxide and water is kind of slow, so I'm just going to wait a little bit. No, let's keep going. Oh, that's definitely more green than it was before. But it's still got a cyan kind of color. Let's just do this. Well, I don't know. I'll try it. Let's just see. I'm going to try it over here. We got to shift to a blue. Now we're like pH 8, and these are getting pretty close to the same color. Look at that. The one on the left is a little more yellow. There we go, folks. That's just a little demonstration that carbon dioxide is indeed acidic. Isn't that nice? You know what, Orion, I should do that. Do some jumping jacks first. Mix both of them in one jar. Let's do that. That's kind of fun. So we're going to do it this way, though. Let's do this. There we go. I'm going to add, let's say, a drop of base over here. No, let's add a drop of base to this one. So there we go. Drop of base. Give that a swirl. Make it violet. We're going to add a drop of acid. Actually, 2 drops of acid over here. There we go. Not quite acidic. Let's keep going. I want to make it acidic over here. All right. So we've got red over here. We've got violet over here. We got pH. Let's do it this way so it's kind of like left to right. We got pH 3 over here. We got pH 10 over here. Now what we're going to do is we're going to mix these two and we're going to see what happens. Let me get a second flask. Give me a second. All right. We're going to see what happens when we mix them up. Let me get a fresh... Oh, I guess I can just pour them. Okay, here we go. Usually the base is a little more concentrated. So I'm going to try to add just a bit of base here. All right, so there's the base. Let's add probably twice the amount of acid. Let's just see. There it is. Isn't that cool? Come on, man, that's cool. You add the acid. Oh, and it reacted. It's a little slow. It went to yellow. That was kind of cool. Probably from the carbon dioxide that's in here that's slowly reacting with the base. Let's see if we can get this to green here, just to mess around. No, let's add a little more. Oh, I'm spilling. There we go. Remember, there's carbon dioxide in here, and carbon dioxide reacts slowly with base. So that's why you see the color shift back slowly to a more acidic color. We'll keep going. Super serum soldier. Thank you there, Una. I appreciate that. Let's see if this does it, the trick. Why is green the most abundant color in nature? You know, I guess, James, I would say black is the most abundant color in nature because most of the universe is dark. What do you think about that? So I'm sorry, James. Just give me a little bit more specifics into your question. I'm not trying to be a smart rear end here. I feel like it turned you into the Hulk, right? You got to drink something green, you're going to turn into the Hulk, of course. Hey, folks, I'm getting I've been staring at the screen for about an hour, and I lose, I just lose it. So, eyes here on Earth. Well, I mean, when I look up at the sky, I mostly see blue. Fallon. So, Fallon, when I look up in the sky, I see blue. I'm not trying to be like combative here. I'm just I want to make sure I understand the question. Oh, so you're talking about why are plants mostly green? Yeah. It's really that technically there's no color. Color is just perception. Hey, PA, thank you. Come on, PA. Appreciate that. It is nice to have these 3 colors side by side. PA, I gotta give a shout out to PA. Just sent me $2. I appreciate that. I'm gonna call it quits here pretty soon. And just so you know, when I call it quits, I flip the camera around is what I do, and then I talk to you for a bit, in case you want to see my ugly mug. But be aware, I am a 57-year-old man. Okay, in my basement. So if that's not something you want to see, BGN, come on now. Thank you very much. Belazar, I appreciate that. Belazar, thank you very much. I appreciate that. I am a chemistry teacher, Una. So chlorophyll, why is chlorophyll green? Because it absorbs red light very well. So when something absorbs red light quite well, it's going to appear green. And the red light is finely tuned for the chemical reactions that need to happen in the 2 photosystems in the plant, photosystem 1 and photosystem 2. So that's what's going on there. Really appreciate there, Velazar. Thank you. Appreciate it very much. Okay. I'm going to flip this camera out. We're going to talk. I'm glad you think so, Limp Biscuit, but I'm gonna burst your bubble right now and we turn this thing around. We're gonna talk to folks here. Oh, let me just get this going. We'll call it quits for the day. So Lord Stormy, it absorbs. Yeah, that's right. It reflects green light really well, and that very well could be because it absorbs red though because the chemical reactions in the photosystems in the plant, that's what takes in the energy to drive photosynthesis. Those are red colored photons that they need to drive those chemical reactions. I am a science teacher there, Baldus. Hello there, James. So long, Una. Yeah, I like to dress up and wear my chemistry shirt for y'all when I do the lives. I hope you don't mind. I am, man, Kyle. I'm every bit of 57, buddy. Every bit. You see that gray hair there? Once I start going gray, I think people notice I'm as old as I am. K Dub, you know it, K Dub. Thank you there, James. Appreciate that. Thank you there, Lim. Appreciate that. The crazy hair comes because there's a bunch of static and I need to get a haircut. That's where it comes from. Thank you there, Rock Bottom. So the name of the experiment I just did with this one over here, I just did a YouTube short on this video that came out. It's my most recent YouTube short. I did a variation on it. This one I called the Rainbow Tower. And if you want to check that out, check out my channel, Tommy Technetium. Say hello. Say, hey, I was in the live today. I try to read all my comments. I might want to do that, Lord Stormy. You're right. Thank you there. Thank you there, Velazar. What is the formula of fluoranthemonic acid? Isn't it HSB07? I don't remember. Jordan, give me a update. I can't remember that one off the top of my head. Thanks there, Debbie. Hey, thanks there, Kyle. Jordan, again, I can't remember. I think it's HSB07, but I can't remember. If you Google it, drop it in the chat. I'd appreciate it. Hello there, Mohit. Hello there, Freak. No, I'm not. I hope not, Adam. I hope I never break bad. I hope I never break bad. SBF5. What was I thinking? I said SB07, of course. I appreciate that. Sorry, I can't read the name, but I appreciate the help. Hello there, CAIE. Green Goblin. Islamic, I don't know what kind of microbes live on the chemical. I don't know what chemicals you're referring to. Which is more acidic? Ethanoic acid or phenol? Ethanoic. I'm guessing ethanoic acid. Thank you there, Rock Bottom, but it's just a guess, Huda. Sorry, Islamic. I don't know. Akira. Thank you, Akira. Nate, I wish I had you as my science student. That'd be fun. We goof around. Of course, we got to get to work, too. It's not all fun and games, right? You do got to learn the material. But yeah, I try to do an experiment in every class I teach. Have I ever had a chemical fall? Yes, I have, Baldist. I have had a chemical fall on me. I was doing a experiment with ether. So, it's very volatile stuff. So we were in organic chemistry lab. I'm a sophomore in college, and we were heating ether on a hot plate. So my beaker was roughly, I don't know, about this big or something like this, and I'm swirling on it on a hot plate. And ether is really volatile, so there's ether fumes coming out of the hot plate. I must have had my hot plate turned on too high or something. So I'm swirling it with my hand, and the next thing I know, I hear this whoop, and there's flames coming out of the beaker. And so I move my hand away like this, and I'm looking at it, and there's flames dripping over the beaker is what it looks like dripping out of the beaker and onto the floor. And so what I naturally did, I just let go of the beaker, and the beaker fell to the floor, and I saw this big boom, and that was it. And my professor, Dr. Benson, was very concerned, and he let me go home for the day. We're doing all right, Ruben. All right, folks. I think that's it for today. I'm gonna call it quits for the day. Just remember that the universe is always having a party, and science gets you on the guest list. So what I mean by that is, like, the universe is always just doing this cool crap, like this phenomena that's happening all over us. And science allows you to see those phenomena in a new way, so you kind of approach the universe as a kid again, and you see all these new and interesting things. You think, oh, what in the world is going on here? How does that happen? And science allows you to think through what's going on and often come up with explanations for it. So in my experience as a scientist, knowing science has allowed me to view the universe through the eyes of a child again. And I see what's happening, and it just gains this new beauty to me. And that's why I say this. The universe is always having a party, and science gets you on the guest list. All right, folks, we'll see you next time. Thanks for hanging out. So long.